Okay, let's continue our discussion uh, on time domain analysis of discrete time systems. So we have seen convolution sum. Uh, Now let's see another very powerful uh, mathematical modeling for discrete time systems, which we use it for this solving or analyzing or designing discrete time systems. I'm doing many projects with senior students using this method. It's very powerful for digital systems. We call it difference equation. That's what we are going to discuss now. So mathematical modeling is very important as an engineer. Mathematical modeling of systems or engineering systems. We have continuous time analog systems, CT, continuous time systems, okay, and mathematical modeling for discrete time systems. Here we are also for discrete time systems and for continuous time systems. So for continuous time systems, we are using mathematical modeling called differential equation modeling. It's called what? Differential equation modeling for continuous time systems. We use differential equation modeling. But when you come to discrete time systems, the mathematical modeling is called difference, not differential. It's as you can see here, the equation we use for discrete time systems. I will explain this using many examples. Very interesting, using MATLAB because we are using this for design analysis of discrete time systems. So it's not differential. For discrete time system, it's called difference equation. Okay, so it is not differential, but we call it difference equation. Difference equation. So when we say difference equation, I mean it is for discrete time systems, right? When you say differential equation, it is for continuous time systems. Let's explain this using example. So when you see continuous time system, let's say one example, continuous time system. We start from continuous time system. We have, let's say, resistor, right? Continuous time systems. Basic components are resistor, capacitor, inductor, and so on. So, okay. So the input x of t, we use t for continuous time, right? Time is continuous here. So let's say resistor, we have 1 ohm resistor, and capacitor we connect 1/2 farad capacitor. Okay, so this will be output y of t. So what is the equation? The equation of a system, this system, which consists of 1 resistor and 1 capacitor, RC system, let's develop equation which relates what? Input with output. This equation will be what? Because our system is continuous time, the equation we are going to develop is called differential equation. So here, this is our current flowing in this circuit. So let's write KVL. So x of t, the input, right, minus the voltage drop across the resistor, which is R times I of t, the current, will give us what? It will give us the output, y of t. Okay, so R is 1, so x of t will be R is 1 ohm resistor, so 1 times I of t, it will be I of t, will give us the output. Okay, so let's say this is our equation number 1. Next, what is the current through the capacitor? Current through the capacitor, I of t, is equal to 1 over C d by dt. You know this from capacitor. The voltage. What is the voltage across this capacitor? Y of t. Okay. So dy of t by dt times 1 over C. So C is 1 over 2. So 1 over divided by 1 over 2, it will be 2 dy of t by dt will be the current. Okay. So this, let's say this equation number 2. Now, this is a current I of t. What we need, when we say system equation, it relates only input and output. What is our input? X of t. What's our output? Y of t, voltage. So in this equation, substitute I of t from here to this equation here. Okay, because we need to replace I of t. So x of t minus, what is the current? The current is, we get it from here, which is 2 times dy of t divided by dt is equal to y of t here. What I have done, it's very simple. I write equation here, KVL equation. This voltage minus the voltage drop in the resistor will give us the output voltage here. X of t, how much voltage drop is the resistor? This one. So it's equal to y of t. Now I of t means the current flowing through the capacitor is I of t. So I of t and voltage, how you relate in capacitor? If you have any capacitor, if there is a voltage across the capacitor, V of t, if current flowing through the capacitor is I of t, so what is the relation between current and voltage? Current will be is equal to 1 over C, the capacitor, first derivative of the voltage. This is characteristics of a capacitor. Always current is equal to 1 over C dV by dt. So that's what we have done here. Then I substitute the current value, this one, from this equation here. So I get now this equation. What variables are there? X of t. What is x of t? Input. Another variable, y of t, which is what? Output. So this equation has only input and output. So if you take this part on the other side, what do you get? It will be positive. 2 dy by dt divided by 2 dy by dt plus, here we have y of t here, y of t is equal to what? Is equal to x of t. You see here this equation? This equation is called first order because the derivative here is first. Okay, it is d square, it will be second derivative. So first order differential equation for which system? For this simple RC system has this equation. So what do you understand? For continuous time systems, If you write system equation, it will be differential equation. Okay, it will be differential equation. Now, how about discrete time systems? Let me show you one example here. Okay. Now for let's see for discrete time system. Okay, so let's take one discrete time system here. We'll discuss this in detail for discrete because that's our I'm drawing here very simple discrete time system. Okay, so this system, what are the basic components? For continuous time system, we use resistor, capacitor, and so on. But for digital systems, our basic components are this one, other circuit. Okay, we have other circuit, which add two signals together. This part, this is one other, this is another other. Just like a resistor, capacitor, inductor for analog systems, when you design digital systems, we use these three basic components. We'll come to that. Other circuit. How about here? Multiplier. This signal in this wire is multiplied by 2, so multiplier. Another element is multiplier. Another component you see is this one, z to the power of minus symbol, which is we call it unit delay element or memory element. Okay, unit delay or memory element. This z to the power of minus 1. So just like the analog case, we have input x of t, output y of t. So in this case, input will be discrete time, x of n, right? Output we get here, y of n is our output. So our system is this one. Our system is here. This case, this is our system. So we have to write equation. Why we need to write equation will come later. It's very important. Equation for this system, which relates what? Which relates input with output. In the case of analog circuits like this, we write equation which relates x of the input with I of the y. What type of equation? We call it differential equation for continuous time systems. For discrete time systems, the equation we are going to develop is called difference equation. So let's see this difference equation. So here, the output here, y of n, comes here, y of n, delayed by 1. So at this point, we'll get y becomes yn minus 1. Okay, we'll see this in detail when we come to the design part. But the output, when you see systems like this, in this case, for example, this output is come here applied to this element. What is this element? Memory element. It will give you the past value. Okay, if you apply y of n, it will give you yn minus 1. What will be the sample before one sample time? Okay, so So here we apply y of n, we get yn minus 1. So this adder circuit, you see this is adder, addition, which add two signals. From this side input comes, from this side input, okay? It comes input, this is our adder circuit. There is another signal comes from here, but this is minus, this is plus, right? As you can see here. So what will be the output of this summer? From this side we apply input, x of n. What is the signal which comes from this side? Output feedback. Output first delayed by 1 and it comes here. So what is that? Output, but it passes through a memory unit, so it will be yn minus 1. So what will be here? X of n, because this is minus, it will be x of n minus y of n minus 1. Okay, y of n minus 1. That is the output of the first adder. Then this signal here, this signal multiplied by 2. Here is a multiplier. Okay, so look here. After adding these two signals, we have a multiplier, multiply the whole signal by 2. What will be the signal? This one. One signal comes from our input, another signal comes from output side delayed by 1, feedback. Okay, these two added together, then multiplied circuit, multiplied by 2. After multiplication, what do you get? 2 times x of n minus 2 times yn minus 1. Okay, then what will happen? This signal continues. Then there is another adder here, okay, another adder here. This signal added with another signal comes from this direction. What is that signal? It comes from here, this direction. Look here, the input, this wire, you see it? It comes here, go to another memory element here, which delays the input by 1. Okay, so look here, the input comes here, go to the delay element, z the power of minus 1. What will be the output? The input delayed by 1. Then this one, this wire goes to the this addition here, plus. Both are plus. So what will be the output of this addition? The output of this adder is our output here. So what will be the output? Output will be y of n will be, signal comes from this side, which is 2 times x of n minus 2 times yn minus 1. Another signal comes from this side, which is x of n minus 1. X of n minus 1. So look here. In this equation, we have output, y is output, x is input. Okay, so if you collect all output on one side, y of n, okay, then if you take this output on that side, it will be plus 2 times y of n minus 1, n minus 1 is equal to, we have input here, we have input here, right? 2 times of x of n plus x of n minus 1. Okay, so this is our equation. For which system? For this system. What type of equation is this? We call it difference equation. It's very important equation, very powerful equation for analysis design of discrete time systems. It's not differential equation, as you can see. It's called difference equation for a system. Let's see one more example. if you see here, this, let's write difference equation. We are asked what? Difference equation of this system. This system, how many components? Here we have one delay element. Here we have adder. Here we have another adder. Here we have a multiplier. Here we have a multiplier. So this real devices, digital devices, they have thousands of multipliers, thousands of memory units, and so on, right? But here, for simplicity, let's take the simple system. It's discrete time system. That's why we don't have resistor capacity. Here, it's made up of what? A multiplier, adder, and a memory unit. Okay, so how we are going to write the out equation? What is the equation called? Difference. The equation is called difference equation. For the continuous time systems like this, we write equation which is called differential equation. Depends on the system. It can be first order, second order, and so on. Okay. Similarly, for discrete time systems, it can be first order difference, not differential, second order difference, third order difference equation. So let's see one more example, how to develop this difference equation for this system. Okay, look here. This is our output, right? From here, output signal comes back. Go to which element? This element, we call it memory element. It will give you a past value, the recent past. So what will be the output here? The incoming input is y of n. It becomes n minus 1. Delay the signal by 1 unit. Then this will go to here. This is other circuit. There are two inputs, right? One is x of n, one is y n minus 1. So what will be the output here? Output of this other circuit. It will be x of n input minus, this is because this is minus here, the input, the feedback signal comes from the output, which is y of n minus 1. Okay, that is the signal at this point. Then we have another circuit element here, multiplier. Multiply this signal by how much? By 3. So what is the signal at this point? After multiplier, it will be 3 times. What is the incoming signal? This one. Okay. The one signal comes from output side, one signal from our input. The two added together here by this other circuit. Then they are multiplied by 3. So x times 3 minus 3 times y of n minus 1. Okay. Both the two are multiplied by 3. So what is the next component? Adder. It adds two signals again. One signal comes from this side, this signal. Another signal comes from this side. What is that? Look here. X of n goes here, multiplied by how much? By 2, another multiplier. So 2 times x of n, input signal multiplied by 2, and it comes this direction. And added with what? Added with this signal, it will give us our output. So what will be the output? For this system, output is equal to this signal at this point, which is 3 times x of n minus 3 times y n minus 1. This is the signal which comes from input side here, x of n and y n minus 1 feedback. Another signal comes from this side. What is that? 2 times the input. So we have to add that. Why we add? Because there is adder here. Okay. So 2 times x of n. Now, y is output, x is input. So take output on the other side. So it will be y of n. Okay. This minus becomes plus. When you take it to the other side, it becomes plus. So it will be 3 times yn minus 1. On this side, we have inputs. First input, 3 times x of n. Then here we have 2 times x of n. So if you add this 3 plus 2, it will be 5 times the input. Okay. So y of n plus 3 times yn minus 1 is equal to, this is our difference equation. It's very, if you have this equation, you have absolute, very clear knowledge about the system. This equation is difference equation, what we call it a difference. We'll see many examples until it gets clear for you. Here you see, from this, let me show you one simple. So what will be the output? Y of n. You see this one, y of n will be 3 times x of n. For this system, y of n output is equal to if you take this on the other side, it will be minus 3 yn minus 1. Okay, plus input is 5 times x of n. This is our difference equation, right? Our difference equation. So what do you understand from this difference equation? In this system, the output at present time n depends on 2 things. It depends on what is y of n minus 1? What is y of n minus 1? The output, the past value, which is stored in the memory, yn minus 1. Okay? The present output depends not only input, x is our input. Okay? Our output depends on 5 times input plus it depends also on the past values because it is causal system. You see the first factor, it is yn minus 1 means the past value of the output determines the present value of the output. So the output is not only depends on input, it also depends on the past value of the output. It has so many applications, this difference equation. We'll come to this in detail. We'll discuss difference equation, we'll see different examples, how we are going to design, analyze digital discrete time systems using difference equation.